This is Bukya Krishna, rule number 20951A2130, subject MTT, branch Aeronautical Engineering, Institute of Aeronautical Engineering, Dundigal. So today I want to discuss about the modulation property of Fourier transform. Fourier transform. In mathematics, a Fourier transform (ft) is a mathematical transform that decomposes functions depending on space or time into functions depending on spatial or temporal frequency, such as the expression of a musical chord in terms of the volumes and frequencies of its constituent notes. The term Fourier transform refers to both the frequency domain representation and a mathematical operation that associates the frequency domain representation to a function of space or time. The Fourier transform of a function of time is a complex valued function of frequency whose magnitude represents the amount of that frequency present in the original function and whose argument is the phase offset of the basic sinusoid in that frequency. The Fourier transform is not limited to functions of time, but the domain of the original function is commonly referred to as the time domain. There is also an inverse Fourier transform that mathematically synthesizes the original function from its frequency domain representation as proven by the Fourier inversion theorem. Definition of Fourier transform. The Fourier transform is a generalization of the Fourier series. It only applies to continuous and a periodic functions. We define Fourier transform of a piecewise continuous and absolutely integrable function x of t by x of omega equal to f of x of t is equal to integration of limits minus infinity to infinity x of t into e power minus j omega t dt. Inverse Fourier transform. We define inverse Fourier transform by using Fourier transform, that is x of t equal to f inverse of x of omega is equal to 1 by 2 pi integration of minus infinity to infinity x into omega into e power of j omega t d omega. These are the properties of Fourier series: linear property, time shifting property, frequency shifting property, time reversal property, time scaling property, differentiation or and integration properties, multiplication and conversion property, conjugate and conjugate symmetry. So frequency shifting property is known as the modulation property. So we should discuss about modulation property. Modulation property. If function f of omega is called Fourier transform of f of t, then Fourier transform of f of t cos at is of into f of omega plus a plus omega f of omega minus a. So we can discuss about the modulation theorem. If f of x cos ax is equal to of f of s plus a plus f of s minus a, and then f of s equal to f of x, f of x equal to 1 by under root 2 pi into integration of minus infinity to infinity f of t cos a t e power of ist dt. f of x equal to 1 by under root 2 pi integration of minus infinity to infinity f of t into e power of iat plus e power of minus iat by 2 into e power of ist dt. f of x equal to 1 by 2 into 1 by under root 2 pi into integration of minus infinity to infinity f of t into e power I into s plus a into t dt plus 1 by 2 root 1 by under root 2 pi into integration of minus infinity to infinity f of t into e power I into s minus a t dt. So f of x cos ax equal to half into f of s plus a plus f of s minus a. Thus the theorem was proved. Thank you.